Today's page in the notebook focuses on powers of x and how changing the power changes our perspective in algebra as well as geometry. We'll start with the four main points. So first, when we take x to the 0, or when we take any number raised to the power of 0, that's going to return 1. It doesn't matter what it is. We could put -4, we could put z, we could put 5,000. It doesn't matter. Anything raised to the power of 0 is going to be 1. And so in an example, we could have 3x squared plus 2x minus 4. And so we can imagine that there's an x to the 0 out here. And so it doesn't matter whatever we put in for x, we're going to get times 1. And so anything times 1 just returns that same thing back. And that's why we call that the constant term. It's constantly going to be -4. It does not matter. X can be anything you want to throw in there. Once I bring that to the 0 power, it turns into 1. And so it just goes away, and that's just our constant term. When we're in geometry, they're going to say that which is dimensionless, that which has no length. They'll talk about a point. And so how big is that point? Are you going to measure it? It's just a point. And so we don't really call that a size. We call that a location or a position, and we'll give you coordinates for that. Now we've come into our linear terms, or our first dimension, and what that means is we've just got one thing. And so what is a power? A power is we're going to be multiplying the same thing over and over, this base here. And the power tells us how many times we're going to multiply that base. And so here we've got 5 times. And so it was just kind of a shorthand because, gosh, could you imagine x to the 15? I wouldn't want to write 15 x's. So there was this shorthand that came up. But when you have 3x plus 4, it's faster to just write the 1x to what it really is than to write the shorthand, which would be x to the 1 power. But just know it's one copy of x, or one copy of the variable, and that's going to be our linear, our line. That'll make that straight line. And when we're in geometry, when we talk about one variable, we're going to talk about one dimension. So length is typically what we'll have. And so when you're given things in one dimension, just think it's one letter multiplied. You're not multiplying 2 letters. You could add letters, but you can't multiply more than one thing. So if we had a square or a rectangle, we're doing length plus length plus length plus length, or you can call them length and width because they're different. We're adding those all together, but they're all just one thing. One length added to another length added to another length. That's perimeter. We're not going inside. Inside would be area, right? And we're not going inside with one. Just one letter is going to be one dimension in geometry. And when that letter, when that's the same, when the length is the same, all the sides have the same, we just call that a square. And so the perimeter of that would be 4 of those x's, but again, they're x to the 1 power. So we're in one dimension, we're talking about length. When we move into 2 dimensions, or quadratics, so in algebra, we're going to see something to the square. That's 2 things multiplied, remember. In algebra, that's going to be our quadratic term. So you might see 3x cubed plus 2x. We might not have a linear term, so then we'll just go straight to the constant. Our quadratic term is going to be the one with the 2. And quad is 4. But what that comes from is the quadratic area. So the area of a square is x times x, or x squared. Quad means 4. We have a square, that's our quadratic term. It's just a name. It's our quadratic term. Now when we move to geometry, as I said, we're multiplying 2 things. 2 things is going to be area. And that's why you'll see, if you see 2 things multiplied, you'll know you're in area. You'll see squared, centimeters squared, or meters squared. Something got multiplied times something else that was a variable, length times width. I'm not talking about pi times something. Pi is a constant. I'm talking about you had 2 variables of length and width, things that will change in your equation. That's usually we're dealing with area. We're multiplying a length, something that goes left, right, and a width, something that goes up, down, and we're creating this plane here. Next, we're going to move into multiplying 3 things. And in algebra, that's called a cubic. And in geometry, when we multiply 3 things, that's our volume. And that's length, width, and height when we have our little box or our prism or whatever they like to call these. But if it's all the same length, same width, and same height, then we have what's called the cube. And so that's where we get the cubic name. It's 3 things multiplied in geometry. And that can be a length, the width, the height, or radius, 3 radii multiplied together. And we'll get there. We'll talk about that in more depth. So let's start with the algebra side of things. So I'm going to label our x powers. When we're in our constants, where x is a constant or y is a constant, what we mean is it does not matter whatever information you want to input. And usually, so when we have an axis here, we're going to call this x and y. X is the input and y is the output. So that means you're going to give me something and I'm going to give you something else. So here we have, when you give me, so x equals 4. I don't care what you give me. You're giving me a 4. That's what that's saying. You're going to give me a 4 and everything else is going to come out. You're giving me a 4. So all the possibilities, you'll have 4 people that will enter a contest. They could lose money, they could win money, but it's only going to be 4. It's always x, your input is 4. What does it look like when your output is always 4? Well, that goes to your answers are 4. So no matter what I put in, I'm getting a 4. I'm getting a 4 all across. And so it's kind of counterintuitive because what you would think is these are y's, they should be vertical, but it's the y's are always the same. The y's are always the same. That's creating a line that's horizontal. So we're going to move on to the linears. And linear is probably the most crucial thing that you can study if you only had one thing you were allowed to study for SATs or college prep or anything you're dealing with. This linear equation here is going to be the heart of Algebra 1. And so I'm going to start with just the graph for y equals x, just our regular old graph, y equals x. And what that's saying is whatever I put in, I'm going to get that right back out. So if I put in a 0, I'm getting that right back out. If I put in a 1, I'm going to get a 1 right back out. If I get in a -1, I'm going to get a -1 right back out. So it'll create a line that's 45 degrees. And from there, you can make adjustments. So one adjustment we make is to the slope or the slant of the line. So right now you can see there's no number here, but if I were to imagine a number, it would be the number 1 because 1 times x is x, right? But we don't ever say that. So right now this is a slope of 1. And you might see an equation y equals mx or y equals mx plus b. And when we're saying the m, that is the slant, that is the slope. And I have a page dedicated entirely to this particular topic. But just know, when you have y equals x, that's a slope of 1. So anything bigger than 1, and we're not talking about negative. Negative is a whole other ballgame. We're talking about fractions or numbers bigger than 1, right? And so if it's a bigger than 1 number, the slope of that is going to be more steep. And if it's a fraction, the slope of that is going to be more horizontal. So this would be something like a 1/3, and this would be something like a 2. And so this number here, you'll see they'll say change in y over change in x. And that's just telling you when you start at one particular point to get to the next point, you'll move that much. Let's actually draw this more accurately. This is going to be your change up, down, and this is going to be change here. So we just have a 1 in front of the x. We can write that as 1 over 1. And it's so every time I move over 1, I'm going up 1, over 1, up 1. And you'll see over 1, up, over 1, up, over 1, up. It's constantly like that. And that is why you can have this is the slope, because the slope is always the same. And so for a straight line, when we move anything past a line into quadratics, then the slope is not constant. It's not the same. And you can't just look at it and tell the slope. And so what I mean by that is let's look at the next graph, y equals x squared. So for y equals x squared, this is going to have 2 parts. It's going to have the part on this side that goes like this, and it's going to have the part on this side that goes like this, and it's going to have a part right here where they meet called the vertex, and that'll be labeled -hk. So when you look at this, when I'm talking about a slope, I'm talking about how steep it is. And so it's really steep up here, but then down here, it's almost a straight line, right? So that's here, it was always 1 up over 1 up over. Here, I barely go over at all, and I'm all the way up a couple, and then I'm all the way up here. So this is not doing 1-to-1 at all, right? It changes. The slope is changing throughout that U. So the slope is not constant. So when you're in a 2, you're not learning anything about slope from this equation, and that's why it's called vertex form, because it's showing you the vertex. And then this here would be called standard form, and of course the 0 and the 1 we don't ever write. And so I'll write the standard form for a cubic. We can move down here. Oh, we don't write the 1s, right? And that again will tell you. So in a standard cubic, it's very similar to the quadratic, except for it's a little flat. So right here, let's really zoom in. Right here on a quadratic, they'll both meet at 1, right? But the quadratic is going to make a sharper turn, whereas the cubic is going to be a straight line here, and that's how this side you can tell the difference. They'll both meet at 1. When you put in 1 and you square it, you get 1. When you put in 1 times 1 times 1 and you cube it, you get 1. And so when you take that to the other side, that's where things get interesting. So it's going to be, again, it's going to be more straight here for the cubic. When you do -1 times -1 times -1, these two will form a positive. And that's why up here, when you look at the U, nothing is down here. You can never multiply the same thing twice and get a negative answer. So all of your answers must be up here. They must be on the positive answer side, right? So these two together will make a positive that leaves you with that negative, and that's why you're going to come down here and have green little curvy thing doing its thing. It's opposite, and then we have this orange curvy thing, and then we have this straight part here. That's kind of how I keep it straight for a cubic. It's got 3 parts. It's got the curve, and then the straight. And then this has just the curve and the curve, but they meet at this point right here. And it immediately starts to jump. It immediately goes up. Whereas this one makes a straight line. That's kind of how you can see the difference between these two graphs here. You won't have to learn much more. I do have a section on graphing and all of the things that you'll need for algebra. But as far as SAT and ASVAB, this is pretty much where they will stop your graphing. So the H and the K, we'll talk about that in a little more detail. First, let's talk about the B. So the B, the reason this is called slope intercept is because we talked about the M. We're going to talk about the B. And for the B, let's draw this again. We've got our OG line. The B is telling us how much we're raising this point here. And so it tells us this is the point 0, 0. And when we make a change, we will move it. Let's give an example. 2x plus 4. We're going to move that up 4. And that makes that new point here. And then we have our 2x. So we once had a slope that went like this, but this is a 2. So this is telling me I'm starting at 0 and I'm going to go up 2 and over 1, right? Because this is a fraction. And we just have to write it ourselves. They will never put a fraction over 1. Remember, the top is the change in y and the bottom is change in x. So we're going up 2 and over 1. And so that gives me my new point, up 2 and over 1. And so we're going to be a lot steeper. So by making it a 2 instead of a 1, we've really steepened that slope. We've doubled it. We went to the point over 1, up 2. And so see, it's really, really steep. And then we've moved this up 4. So now we're just doing that way up here. So the M will tell us the steepness, and I get way detailed into this later on. But when we move to the quadratic, that is not B. That is not telling us where this touches the line here, unless this H is 0. But the H isn't 0. That are not the same thing. They're not telling you the same thing. And then that leads me to, you might see standard form here. And so with standard form, you're going to end up with the X's and the Y's with some number. And so these letters A, B, and C, they're just placeholders. Eventually, you will be given an equation like 3x cubed plus 2y squared, or 2x squared plus d. We'll call that 8. You'll be given numbers that will go there, but the x will always stay in x. The x squared will always stay in x squared. That's what is going on. You're given different inputs. But this is a placeholder because I couldn't write every possible constant you're going to be given. They will give you constants. And so they'll give you like 3x plus 2y equals 4. So when I say ax plus by, they'll put numbers there, but the x and the y will stay. These are going to be lines, and you can write them in two different ways, but if you're given this green line here, you have to do some manipulation before you can tell what the slope is. The slope is not 3. It's not the thing touching x. You must get it into some kind of form where this y here needs to be all by itself, and so we would have to get rid of the 2, and all of this would need to move away, so y is by itself, and then we would have to get it in this form y equals mx plus b. So you can't just look and say, oh, it's touching x, that's a slope. That's not what that means. So the only way that you can look and see a slope is if you are in the slope intercept form. In that form, it will show you. And the reason it shows you the intercept, because the intercept is what happens when x is 0. So if you put x is 0, all this goes away and you just have b. That's why that's that way. But that has nothing to do with the quadratic. The quadratic does tell you up or down. However, you're also going to be moving left or right. And that's the thing that's in parentheses. And that's why it's so interesting, because they'll show you negative hk. And it's because that thing in parentheses is opposite. So the vertex is going to be, so normally the vertex is at 0, 0 for y equals x squared. But if we want to change it, we want to do y equals x, let's say minus 3 squared. The minus 3 right here is a negative hk. Well, regular hk is at 0, 0, right? So let's add a plus 6 to this equation here. So our k would be the same, it would be 6, but our h would be opposite. Our h wouldn't be a negative 3, it would be a positive 3. And that's very weird, but whatever's in the parentheses is going to be your left, right, but you do opposite. That's why they say the vertex is negative. Let's clean this up a little bit. When I have the equation y equals x minus 3 squared plus, let's do 2 to graph that easily. What I'm saying is right here in the parentheses is my code for, let's even label that better. In the parentheses is my code for left, right, and in my outside is the code for up, down. Here there is no code for left, right. If you were to have something in the parentheses per se, you would end up not in the right form, and this would not be slope intercept. You would have to distribute, and then once you got that negative 12, then that would add to the 2. So then you would be given 3x, and then minus 10. Then you could figure it out. Now it's in the form of y equals, but if it is not in that form, you can't figure it out. So when you have that here, lines, what does a line even mean to slide it left or right, right? It's a line. It goes on forever up and down. And so this in parentheses, in order to understand anything about it, you can't just look at it and say, oh, it's sliding over or it's doing this or that. You'll need to distribute, and then you'll be able to tell what's going on. And at the quadratic situation, well, what is hk? And it is telling you over 3, so over 3 up to 1, 2. So now my vertex is going to be there, and then I can just draw off of the vertex. Same here. I'm normally here at 0. So if I have, let's say, plus 4 minus 5, we change it to that. Well, this is my over. So plus 4, we're going to do opposite. It's negative hk. So plus 4, I'm going to go to negative 4. And then negative 5 is the same. That's a regular k. So I'm going to go negative 5. So where I was here at 0, 0, I now went negative h, which h is 4. So negative h, and then leave k alone. And so now I'm starting, and then I've got, remember, this kind of flat, and it goes up and it goes down. And so one thing you might see when you're in algebra is zeros. That is not what we did here. What we did here is graph, okay? So I'm going to put these back to their OG graphs, and then we'll just go from there. So OG graph here, and let's make this line. That's the OG graph, that's the OG graph, and this is our OG graph. So when we're talking about zeros, what they mean is we're going to give you a situation where y is 0. That's a particular situation, okay? They're asking about when does the little thing cross this line right here, okay? And so right now, the way I've drawn these, it crosses here, and it crosses here. But you might see something that doesn't look like y equals x cubed. You might see y equals 3x cubed minus 2x squared plus x minus 8. And that is going to have some humps to it. It's going to do some stuff. And it should have 2 humps because it's x to the 3. And the reason being is you have that first line here. Then you have where it does this thing here. And then you have where it comes up here. So this thing in the middle will do things, and these humps will raise based on what all is going on in here. And so when we ask for zeros, this here tells us the most zeros you could have. So the most zeros I could have is a graph that kind of humps like this. This would cross at 3 places, not just 1. So the u is really easy to show people. If I had a u, y equals x squared, but I'm going to raise that up 3 and move it here. Well, now it never crosses this line. So there is no place it doesn't touch. It doesn't touch once, it doesn't touch at all. So that's why they say at most 2, because I could have 1. Let's change that to a minus 3, and all of a sudden x squared minus 3 comes down here. And now it's not any wider. I was just drawing it wider because I can't draw. So it's going to come down here, and now there'll be 2 places where you have 0, where you have y is 0, where you have the answer is nothing, right? Where you have the answer is nothing. Here you had the input was nothing, and here you have we're trying to figure out what the answer is when my output is nothing. So it's a special case when they ask for the answer, when they ask for zeros. Zeros isn't graphing necessarily. You can graph to find the zeros, but we want to be real careful with mixing up. A graph is going to have an x and a y that changes. It'll change, and you can see how that changes. What happens if I put in 7 hours of work instead of 4 hours? Or what if I take out $20 a week instead of 15? Just all kinds of scenarios that we have these graphs for. And so the graph is separate from finding the zeros. The zeros is a whole separate discussion. So here I am not talking about the zeros. I'm not talking about how to find the zeros. I am purely talking about the graphs, the OG graphs, right? So now we move into geometry. And so when we're talking about geometry, we'll have x to the 0, x to the 1, x2, and x3. And when I say x to the 0, I mean that which is dimensionless, the point, okay? When they give you a point, they're talking about, first you'll get a point on a number line, and that's like x is 5. Then they'll move and they'll give you an axis that looks like this, and they'll tell you the first part is where you're moving along this line, and then they'll tell you the next part, which is where you're moving along the other line. And then here, now you're given 3 axes, and this is when it comes out of the wall, that 3D. So it'll tell you how to move on the left, right, how to move on the up, down, and then how to come out of the wall. And you're still going to end up, though, at a point. In all of these, you're going to end up at a point, 1 point. And that point doesn't have a size. It's just telling you where the point is. It's a list of coordinates. It's not telling you a size. You'll get another one, and then you can tell the size between those. But for right now, you're just given a point. It's that which is dimensionless. That's what they call point. We move into 1 dimension, length. We move to 2 dimensions, length times width. And then we move into 3 dimensions, length, width, these are times, and then depth or height, depending on what your book says. So when we have something that just has a length, it's to the 1 power. It's a distance. We're measuring perimeter or circumference. So for instance, let's say we have a box. We're going to measure a length and a width, a length and a width. So we have 2 lengths and 2 widths, but all of those are to the 1 power. We are not multiplying more than one thing. We are in 1 dimension. That is just length. That is just distance. It is not covering anything with a rug. It is not wrapping it. It is not filling it up. It is just walking around the perimeter. When we are in circumference, that is also 1 dimension. So anything with a circle needs a pi. And then we are in 1 dimension. So we have 1r. So we can take the next, which is area of a circle, which is area is 2 dimensions. And so when we have x squared, so a rectangle, when we're taking the area, you multiply the length times the width to get that area. When they're both the same, when you're multiplying length and width, but they're the same, that makes a square, and that's why we have x squared. I'll come back to surface area in a moment. When we are in volume, you'll see a 2 here to indicate 2 things are multiplied. You'll see a 3 here to indicate 3 things are multiplied. And you won't see a 1 here because it's just a length. We've done this since kindergarten. So we didn't even know what exponents were when we were talking about length. And that's why people have a hard time with perimeter and circumference. those aren't dealt with for 6 years the way that area is. So pi r squared is probably the one you're going to have memorized. And then you can just think this 2 is going to come down here in front of it when you move to a smaller dimension. And this 2 goes away and becomes a 1. So now when we go from this area down to a circumference, it's a 1, we're in one dimension, and that 2 that we had earlier is in front of it. So that pi r squared is the one you ever memorized, and the reason you memorize that is it's over and over again everywhere in all sciences. It's all over the place for high school curriculum. So pi r squared, that is commit to memory, and then you can remember that 2 comes down for the circumference if you ever get asked. Remember, when you're in one dimension, it's 1 radius. When you're in 2 dimensions, it's 2 radii. So when you're in 3 dimensions for a sphere, which is I put circle, we're expanding that into a sphere, and this is the one that has the 4/3. And you can think of it, it has the 3 from here, and then it has the 2 2s from here. I don't know how you want to think of that. That's not what happens. When you get to honors geometry, they tell you how to derive that from 2 half circles, and so that's where that comes from, those 2 half circles added together. So that is volume, and very rarely do you add, or will you do that on a test for college or for ASVAB, but rarely doesn't mean never. And so just be familiar that when you're in third dimension, when you're in volume, volume is 3 things multiplied, 3 radii, r, 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 I'm a pirate now. Length, width, height, 3 things multiplied. And when you have a same length, same width, same height, we end up with a cube. And so that's the first part of this video where you can see what happens when we have different powers of x. So here in part 2, I wanted to just compare and contrast the different formulas. So when we're working in one dimension, when we're looking at the perimeter, I mentioned that we're going to be adding this width, this length, this, and this here. So we're going to be adding 2 widths plus 2 lengths. When those are all the same, we have an L, an L, an L, and an L. So we're doing L plus L plus L plus L. That ends up being 4 L's. And that's just to the 1 power. All of this is to the 1 power. We would never write that, but we know we're in length because nothing's multiplying. This is 2 W's. I'm not multiplying a variable times a variable. I'm just saying I have 2 copies of that W. Okay? So that's not the same thing as multiplying 2 variables. When we're working with circles, I'm going to skip over triangles for a moment. When we want to do the perimeter of a triangle, that's actually going to be done when we work on the distance formula and Pythagorean theorem. So it's actually further on in the lessons. So that's why we don't have perimeter of a triangle, because it's not that simple. Circle, you're in one dimension for the length, and so we put a 1. And remember that 2 from the area, I'm going to give that away right now, that 2 from the area comes down here. And so for circumference, it's 2 pi r when we're taking the distance, just the distance. Now we move into the next dimension. And so you can see when we're doing area, we multiply 2 things. Area is 2 things multiplied. And so 2 things multiplied here is a width times a length. And that's your area. But when it's a square, those 2 things are the same. And so length times length. So that's something to keep in mind. We're not adding a length plus a length plus a length plus a length to see like building a fence or taking a string around something. We're carpeting the inside. We're painting the wall. We're going completely inside. We're now going up and down all through it. Okay. That's what's called a plane. So here we had lines. And now we're working in 2D. And these are called planes. We're inside. We're in a plane. Now what happens when we take planes and add them together? So plane, 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 all of these planes. Well, remember I said I was going to get back to my surface area video? So when you're doing these 3-dimensional objects and you just want to put something on the outside, that's called the surface area. And so you actually have to imagine that you're taking this rectangle, which is an H times an L, and you have that on the other side here. So those are the 2 orange. So we have 2 of those, H times L's. Then we have these green ones up top here. Okay, so we've got the top and this green one. And those are W times L, and we have 2 of those. And then we have these corners here, which are W times H, and we have 2 of those. So you see, we're multiplying 2 things. So 2 things is an area, even though we're taking it of a 3D thing, and that's why I saved it for later, because it belongs in 2D, but we need to have a 3D object to take that. So back up here for area, it's going to be taking a length times a width, and then a length times a height, and then a width times a height, and however many you have of those, okay? You're going to be working with taking individual areas. Don't be afraid to dissect. Don't be afraid that there isn't a formula. There isn't a formula for that. You do actually have to go in and take the formula for this square, or it's a rectangle, W times H. Take the formula for this rectangle, take the formula for this rectangle, and add them together to get 6 sides. It is that involved. Surface area is that tedious, but it's not hard. All of those are these are just rectangles. You're just taking an area. You're just taking a length times a width, right? So what would the surface area of a cube be? Well, you're taking this square here, which is length times length. That's one area. And then you need the area of this, which is also length times length. And it's 6-sided. So you're going to take 6-sided length times length, or 6x squared. 6 areas. So the surface area of a cube is 6 areas. The surface area of this guy is going to be 6 different areas. You're going to add the 6 areas. Okay? So now we are on volume. That's when we actually don't want to wrap it. We want to fill it. We want to fill inside of this with water or whatever we're doing. We're filling it up. So we're in volume. We need to multiply 3 things. So length, width, height. And that is a space. So you'll see point, line, plane, space. Spaces are 3D spaces. Now what happens when it's a square? As we discussed, it's going to be length times length times length. So just remember, how many things you have multiplied is what dimension you're in. And so triangles are not hard for area. They're just cutting this little rectangle guy in half. Look at that. You just cut her in half. So you figure out whatever the area is. Okay? So whatever the area is for, imagine it's a rectangle. You don't even imagine it as a triangle. You say, so let's say you're given this guy as a triangle, or you're given this guy as a triangle. You have to imagine the length times the width. You have to imagine what that would be for a rectangle. Solve that, length times width, or length squared, and cut that in half. So that is your job, to imagine an area. That's the way that we find triangles, is we imagine the area of the square or the rectangle, and then we cut that in half, because that's all a triangle is it's that rectangle cut in half. Perimeter is a lot more challenging for triangles. Circle area is in 2 dimension, so we have a 2, of course. I gave that away earlier. So 2 r's. We always need a pi for circles, and that's it. Just 2 r's and a pi. I mean, this one's the easiest one to remember. Everything needs a pi for a circle, and you are in area, you're in 2. If you're in volume, you're in 3. You'll need 3 r's. And remember, this is the one that takes that 3 and puts it here, and then it adds these 2 2's for the 4 up there. And that's not actually what happens. That's a trick for your brain. You'll find out what actually happens in honors geometry. So when we talk about, one thing I wanted to notice is they talk about congruent, and then they talk about equality. In geometry, numbers like measurements can be equal. I can be 5'5" and you can be 5'5". Our heights both equal 5'5". However, you don't equal me. And even if they took me and gave me a twin or a clone, that guy doesn't equal me either. These shapes, they're not the same shape. And if they were equal, your clone would be going to jail for things that you did, or vice versa. You're not equal. Your measurements, everyone's measurements can be equal. All of our measurements can equal 150 pounds or whatever they're going to equal, size 8 shoe. The measurements can be equal. but the shapes themselves don't equal each other. You are not equal to another shape. Two shapes are different. So when you come to equality, I just wanted to cover that terminology, and this seemed like the best place to do it. Hi friends, click the link in the description for all of the worksheets that go along with today's video, and if you want to go through the notebook from the beginning or dive into another topic, check out the other videos on the channel. And of course, it wouldn't be a YouTube video without the obligatory begging, so I put a lot of effort and time into this. I just want you to get something that's not a random AI generated, blurb of nonsense. I really want people to learn, and so I can continue to do that if you can continue to support me, and so I would love a like or a subscribe, anything that helps the algorithm, and if something clicked or if something confused you, or if you want to dig into something I haven't covered yet, say so in the comments. Thanks for watching, and we'll see you on the next page of the notebook.